Hello, 7th grade. This is Miss White, and today we're going to do lesson 12, division of integers. So for our example in exercise 1, recalling relationships between multiplication and division, I will start off using the multiplication problem of 4 times 6 equals 24. Now if we rewrite this problem as 6 times 4, we still get our value of 24. Now, let's make this a division problem. We will have 24 divided by 6, and that will give us 4. And if we have 24 divided by 4, it will give us 6. If you need to pause the video to look over the relationship of the multiplication and division problems, please take this time. Now, we are going to do a very similar thing to what we did in the equation square and put it in the integer circle. Remember, integers can be positive or negative numbers. In our integer circle, we're going to use negative numbers to solve our equations using the similar numbers of 4 times 6 equals 24. So let's do 6 times 4 equals negative 24. Or we could write it as 4 times negative 6 equals negative 24. Let's do negative 4 times 6 equals negative 24. Or 6 times negative 4 equals negative 24. Let's look at our top one here. We set negative 6 as our negative number, and we know that a negative times a positive equals a negative. When we look over here, all we did was switch these numbers, and we still got the same value of negative 24. The one below, instead of giving 6 as our negative number, 4 is our negative number. So we have negative 4 times 6 equals negative 24, or we flipped our two numbers and we have 6 times negative 4 still equals negative 24. Now let's say we set both of those numbers as negatives. So we have negative 4 times negative 6. That is going to give us 24. Remember that a negative times a negative equals a positive number. Or if we switched them around, we would have negative 6 times negative 4 still gives us positive 24. Now let's move down to example 1. Please pause the video to record our equations and our equation square. Now in example 1, we are transitioning from integer multiplication rules to integer division rules. So let's look at our first equation that we have above in our integer circle here. We use negative 4 times 1 equals 24. Let's go ahead and put that in our equation square below. Now we're going to write the rules for division for this. So the first one we are going to have is negative 24 divided by negative 6 equals 4. The other way to write this is negative 24 divided by 4 equals negative 6. Let's do the third equation up here. So now we're representing negative 4 times 6 equals negative 24. Sorry. The first division problem relating to that is going to be negative 24 divided by negative 4 equals 6. and negative 24 divided by 6 equals negative 4. Now we're going to use our next equation from up here. We have negative 4 times negative 6 equals 24. All right, so now our division problems are going to look as such. We have 24 divided by negative 4 equals 6, and 24 divided by 6 equals negative 4. Please go ahead and pause the video if you need more time to write all of this down. Let's move on to the next page. Ultimately, in our last examples, I was showing you the rules for dividing two integers. A quotient is negative if the divisor and the dividend have opposite signs. A quotient is positive if the divisor and the dividend have the same signs. Let's move on to the next page. Exercise 2. Is the quotient of two integers always an integer? Is the quotient of two integers always an integer? Use the workspace below to create quotients of integers. Answer the question and use examples of a counterexample to support your claim. For this example, I'm going to use the numbers that we used previously. We had 6 times 4 equal 24. Well, now we want to know about dividing two integers. Is it always an integer? So let's look here. I'm going to divide negative 24 by 6. Negative 24 divided by 6 gives me negative 4. So in this case, yes, this is an example of an integer quotient. Now, let's do another problem. What if we had 6 divided by negative 24? That will give us 6 over negative 24. When we simplify that down, we have 1 over negative 4. That gives us negative 1/4. Well, let's look here. We have an integer divided by another integer. But our answer is a fraction, and fractions are not integers. So this counterexample has a non-integer quotient. So our question asks, is the quotient of two integers always an integer? Our answer is no. In my first example above, negative 24 divided by 6 yields an integer quotient of negative 4. However, when I switch the divisor and the dividend, the quotient divides a number with a smaller value by a number of a greater absolute value, making the quotient a rational number, our fraction, between negative 1 and 1. And dividing 6 divided by negative 24, the quotient is 6 over negative 24, and that equals negative 1/4. And that is not an integer, but it is the opposite value of the fraction 1/4. This counterexample shows that quotients of integers are not always integers. Let's move on to exercise 3. Different representations of the same quotient. Are the answers to the three quotients below the same or different? Why or why not? So for A, we have negative 14 divided by 7. We know that that will be negative 2. We have a negative number divided by a positive number will give us a negative number. For B, we have 4 divided by negative 7. That means our answer is going to be negative 2. That is because a positive divided by a negative number gives us a negative number. Now C is a little trickier. Because we have our negative value out front, C, we have negative 14 divided by 7. Well, we have our negative out in front of our equation, and then we know 14 divided by 7 equals 2. So we know this value is negative 2. The answers to this problem are all the same. We have negative 2. In part C, the negative in front of the parentheses changes the value inside the parentheses to its opposite. The value in the parentheses is 2, and the opposite of 2 is negative 2. For our lesson summary for today, the rules for dividing integers are similar to the rules for multiplying integers when the divisor is not 0. The quotient is positive if the divisor and the dividend have the same signs, and negative if they have opposite signs. The quotient of any two integers with a non-zero divisor will be a rational number. If p and q are integers, then negative p over q equals negative p over q equals p over negative q. All right, great job today, 7th graders. I will see you in class.